Derivatives of trigonometric functions, part 1. The first thing we're going to do is just learn our first rule. Our first rule is that the derivative of sine equals cosine. This is kind of an interesting rule. The derivative of sine is cosine, and if you know much about trig, you know that sine and cosine are just out of phase by 90 degrees. So let's look at the graphs. It's pretty interesting. So here's the graph of sine, and notice that at pi over 2, the line tangent to the graph is horizontal. So the derivative should be 0 at pi over 2. Well, the derivative of sine is cosine, and in fact cosine is 0 at pi over 2. And in fact, as we would expect, every time sine has a horizontal tangent line, that point is a 0 of cosine. Let's look a little more. Notice that whenever sine has a negative slope, cosine, its derivative, is negative. And whenever sine has a positive slope, cosine, its derivative, is positive. So the derivative of sine is cosine. There's another rule similar to that. The derivative of cosine, well, it's not sine, but it's negative sine. So the derivative of sine is cosine. The derivative of cosine is negative sine. Now, where do these rules come from? You have to start first with two fairly interesting limits. One is the limit of sine x over x as x goes to 0. This is a function that's not defined at 0 because I'd have 0 over 0. But as x gets closer and closer to 0, the quotient is getting closer and closer to 1. The other limit is cosine x minus 1 over x. That also has an indeterminate form of 0 over 0. And so it's not defined. The quotient is not defined when x equals 0. But the closer that we get to 0, the function is, the overall quotient is getting closer and closer to 0. And then we use both these limits when we go to find the derivative of sine or the derivative of cosine. And it involves some trig rules and some manipulations. Now, you're not responsible for this. I just thought you might want to see it. What you are responsible for is using these rules. So let's do that. Let's find the derivative of sine over cosine. Well, sine over cosine is a quotient, so I need to set up the quotient rule. Well, quotient rule, derivative of the first times the second minus the first times the derivative of the second, all over the second squared. Now you have to remember what's the derivative of sine and what's the derivative of cosine. When I take the derivatives, this is what I get. Next, I'm going to simplify my numerator. I have cosine times cosine, and then I have minus sine times a negative sine. So those two negatives are going to cancel. So when I simplify the numerator, I get cosine squared plus sine squared. Now you might recall that cosine squared plus sine squared equals 1. And so this simplifies to 1 over cosine squared. And I'm going to rewrite that as 1 over cosine, the entire quotient squared, so that you can see this is the same as secant squared. So the derivative of sine over cosine is secant squared. And in fact, we just proved a new rule. The derivative of tangent is secant squared. So, three rules you now have. The derivative of sine is cosine. The derivative of cosine is negative sine, and the derivative of tangent is secant squared. The other three rules I'm just going to give you. If you look down the left-hand column, you see you have the derivative of sine is cosine. The derivative of tangent is secant squared. Then the derivative of secant is secant tangent. The right-hand side mimics the left-hand side, but notice that with the co's, every co has a negative derivative. So what I like to say is the derivative of a co is negative. The derivative of a co is negative. And I'll leave you to think about that. Take care, and I'll see you in part 2.